Okay, we're going to continue the online lesson by going over methods of collecting sample data. This is actually section 1.4 still. We're on page 6 of the course packet. So the first thing we do in statistics is we actually go out and collect data, and it's important to collect that in a manner that makes your results believable. For instance, we went over a voluntary response sample in the previous lesson, and that's not the best way to collect the data. So two different types of studies would be an observational study. An observational study, you're just observing specific characteristics that people do or animals do, but you don't try to modify the subjects in any way. An experiment means that the researcher will actually give the subjects a treatment to follow. For example, you might tell the subjects to smoke or not to smoke, and then you would record whether or not they get cancer. And so an experiment requires usually more work, more money, and it's not always feasible or ethical to do. So we're going to go over the 3 types of observational studies. These have to do with the timing of the study. So the first one would be a cross-sectional. Data are collected on current characteristics of subjects. So for instance, do the subjects smoke currently? Do they currently have cancer? The second one would be a retrospective. That's probably the most common. Data are collected on the past characteristics of the subjects. So for instance, have you smoked in the last 10 years? And have you developed cancer in the last 10 years? And the prospective, that means that the researcher follows subjects' characteristics into the future. So if you agree to participate in a study, then what you do in the future will be recorded. Your characteristics or your behaviors in the future will be recorded. Okay, so moving on to the next page. The reason we would do an experiment versus observational study is to control for what we call confounding variables. So the confounding variables are other variables that aren't included in the study, but can have effect on one of the variables that are. So if we're monitoring cancer and we're recording whether or not the patient smokes, then a confounding variable would be maybe diet or exercise. So those are also things that would affect whether or not the patient developed cancer. And so they might be confounding with the smoking. So the cause of the cancer can't be determined because of these confounding variables. Is it because the patient smoked? Is it because he had a poor diet? Is it because he drank alcohol? Those are all confounding variables. And the reason that we do an experiment is because we can control for these by randomizing the treatment. And so people that have poor diets would both be in the group that didn't smoke and in the group that smoked. And that's how we can control for these confounding variables. Okay, so we want to plan an experiment that we can control for these confounding variables. And the most important thing to do to control for the confounding variables is to randomize the treatment. And so you randomly select who would smoke and who would not smoke, and that way healthier people wouldn't automatically be in one group or the other. It would be random. And so randomization is really important. Subjects are randomly assigned to treatments. Replication is also very important. More than one subject is assigned to each treatment. Because we don't want to just look at one subject that smoked and one that didn't, because there's variation with the effects of smoking. And so we want to get more than one subject. Okay, let's see. And then the last one is what we call blinding. This means that the subjects don't know what treatment they got. And so we see the placebo effect a lot when subjects get a certain treatment. And so we sometimes give subjects a sugar pill as a placebo because individuals will often feel better just because they think they're getting medicine. And so we want to control for that as well. All right, so we're going to go over different sampling methods. How do we select the individuals that are in our group that we're going to sample? So the most common sampling method is a simple random sample. We abbreviate that SRS. And to take a simple random sample just really means that everyone in the population has the equal chance of being selected. So it's like putting all the names in a hat, shaking the hat, and then selecting names. But we don't do that anymore. We do everything on the computer. But if we had a list of names from the population, we would use maybe a random number generator to select those names. And that would be a simple random sample. So here's an example of a simple random sample. We had 450 Math 105 students, and I had a list of those names. I could label them from 1 to 450. And then I can go to the computer or my calculator and just randomly select 50 numbers. And those are the students that would be included in the survey. Because simple random sample is the most popular way of sampling, but there's other ways as well, and there's reasons we would do something other than a simple random sample. So the 4 other ones are systematic, convenience, a stratified sampling, or a cluster sampling. So we'll go over each one of these definitions. So systematic just means you're sampling in a systematic way. So we select some starting point. That's usually done randomly. And then select every case individual in the population. So we have to have some way to actually list everyone. So we can maybe alphabetically list everyone. And then we select the 5th individual. And then from there we select every 10th individual. So we systematically sample. Okay. The convenience sample is not a very good way to sample individuals. That just means you do things whatever is convenient. So you use the results that are easily obtainable. For instance, I'm going to ask you all survey at the end of the lesson, and it's pretty easy for me to use you as my sample because it's convenient. I can just give you a link to a survey. Hopefully you'll still do it though. Or if I wanted to collect information about students, I could just stand outside of Holt Hall because that's where I work in Holt Hall, and it would be pretty easy to just stand out there and ask students the information I wanted to collect. So that would be a convenient sample. And a lot of times these are biased as well because you're not getting a representation of the whole population. Okay, so the next 2 are stratified and cluster, and these are the ones that are fairly easy to get mixed up. So we'll go over stratified first. So a stratified sample means that you're subdividing the population into strata or groups. And then you take a random sample of subjects within every group. Okay, so I emphasize the every group because that's what makes it different than the cluster sampling. All right, and then a cluster sample, you subdivide the population into clusters or groups. So it starts out the same way as a stratified sample, and then you randomly select one or a few clusters to survey. Within each cluster, you survey everyone. Okay, so the difference between a stratified and a cluster is really what you do to each group or cluster. So with the stratified, you are going to every group, but within a group, you're only taking a random sample. In a cluster sample, you're not going to every cluster, but when you get to a certain cluster that you selected randomly, then you survey everyone within that cluster. Okay, so that's the difference between a stratified and a cluster. So we're going to work through a few of these examples. So for the following examples, state which type of sampling scheme is used. So we have 49, 34, 48, 55 students are selected from freshman, sophomore, junior, and senior class with 500, 496, and 348, 481 students respectively. And so we want to state which kind of sampling this is. And this would be an example of stratified. And the reason for that is the population is split up between freshman, sophomore, junior, and senior. And the researcher went to each strata and selected a random sample. So 49 is a random sample from the 500. 34 is a random sample from the sophomores, and so forth. So each strata was visited, but within each strata there was only a random sample. Okay, the next one says a tax auditor selects every thousandth income tax return that is received. This is an example. So this would be an example of a systematic. Because they're sampling in a systematic way. They're taking every 1,000th income tax return. Okay, so let's go to the next one. An IRS analyst processes on tax return every 10 minutes. So 240 returns are processed in her first week of work. Her manager checks her work by randomly selecting a day of the week, then reviewing all returns that she processed that day. So this is an example of a cluster. And the reason that it's a cluster sample is because the survey is clustered into days of the week, and they're only selecting one day of the week, but within that day they're reviewing all the returns. And so that's the key word there, all returns that day. So the clusters are the days, and then they're only selecting one of those days, but looking at all the returns. Okay, and then the next one says a pharmacist typically fills prescriptions by scooping a sample of pills from a larger batch that is in the stock. A pharmacist thoroughly mixes a large batch, then selects 30 of them at random. And so this would be a simple random sample. Okay, so he's just basically each one of the pills has an equal chance of being selected, and he selects 30 of them at random. All right, that's it for that lesson. You'll have to answer a few questions after this.